All right. We're going to start a new discussion, and here we want to particularly point out that the 2D integral, the double integral, uh, the most simple case is in the rectangle region, right? So here we could have the double integral to be written in iterated integral. So here, I think we should use the color. For the y, this is we integrate x first, and so x is horizontal, the horizontal coordinate of a straight line. All right, and so we fix the y and integrate about x. So this is a type 2, and we could also integrate the y variable as the interior integral variable. All right, so here we fix the x value, and then integrate about the y. So that is the vertical. So this is the type 1 region. But this is the most simple case. A more general case is that we could deal with, um, yes, like this, or this. Okay, so if we integrate along vertical line first as the interior integral, then this is type 1 region. And if we integrate on the horizontal line as the interior integral, and then this is type 2 region. Okay. All right. So so if we do write the integral, iterated integral out, then this is, as we write it, y equals y bottom of x to y top of x dy, and the integrand is f of xy, and then we have the x is going to be from a to b. This is for the type 1 integral, iterated integral. And for the type 2 integral, though, we'll have okay. And this is what we're going to get. So things are could be very complicated, and sometimes we got to really practice with a lot of those conversion and setting up uh, the limits and the bounds for the integrals, and those are the important feature we need to pay attention to. And one thing we always pay attention to is that for whatever type 1 or type 2 region you set up the iterated integral, for the exterior integral, the bounds are always constant, no matter what you do. But this is the ultimate feature of the double integral with the definite integral calculation by using the iterated integral. Okay, so let's just practice a little bit. And for example, we want to find the integral for the function. Well, let's just give the function directly x plus 2y And here, this domain integration D is the region that is bounded by actually two curves. And this question is particularly hard because it doesn't really tell us where exactly the region is. We have to figure it out. And so our first step, so the first step in our calculation has to be that we need to figure out the domain D by finding all the intersections. Well, one good thing to do is that always that you want to just draw this diagram to illustrate the roughly where the domain is. Okay, so how do we plot? I guess we need to plot two curves. The first one is, well, the first one is this. When x equals 1 and a -1, y will be equal to 2, I guess. So the curve looks like it has to be a parabola, right? It is a little bit narrow than the other parabola we would typically see. And then, oh, I think we should mark. So this is the y equals 2x. What do we mean by that? This means that on any point, for any point on this parabola, for example here, the coordinate of this point will be x and y, right? The coordinate will be x and y, and obviously the y value is completely determined by the x value, vice versa. If you have a specific y value, oh, you may have two different x value, but no matter what, the x value will be determined. Okay, so now let's look at the second curve. So y equals 1 plus x squared. When x equals 0, y equals what? Y is equal to 1, I think. Then I think this curve will be opening up, right? Um, this curve will be opening up, but how wide it is, how about we find the intersection of this second curve with the first curve? How do we do that? Well, I think we did this before. Um, so the thing to do is that we actually need to get a pair value, x and y, such that the x and y satisfy the first equation and the second equation at the same time. So we just need to solve this system of equations to get the x and y value. So the left-hand side of the two equations are exactly the same. So that means 2x squared. 2x squared equals what? 2x squared, I think, equals 1 plus x squared. So this means x squared equals 1. So x equals plus or minus 1. Okay. When x equals plus and or minus 1, what is y? So when x equals 1, y equals 2x squared, which is a 2. So the first point we see is 1, 2. When x equals -1, y equals 2x squared, so which is also 2. So the second point is -1, 2. So the curve, the second parabola will look like this. Okay, so now we can see where the domain is. It is right over here. It is bounded by those two parabolas, right? And obviously, when we plot those vertical lines there, it looks like we treat it's a sort of so maybe you should it is easier to treat D as type 1 region. Why is that? Well, because if you if we draw any of those vertical line within the domain, we can see the top and the uh, bottom ends of each of those vertical line will be always lined on those two curves. So this red curve is y equals 1 plus x squared. This curve in black is y equals 2x squared. Okay, so if we treat this as type 1 region, then we have universal representation of the top and the bottom boundary for the y variable. This is a critical. So we decide to write the domain D as in type 1 region. How do we do that? Remember, for the type 1 region, we fix a number for x first. So what are the region or interval for the x value? Okay, we should see the intersection point will be 1, 2, and the -1, 2. So the x value will have the limit from -1 to +1. All right. So for the y value, then what? The y will be starting, if we try to look at this line segment vertically, for example, and here this is one x value, giving this x value or lower bound for the y is starting at this point, and this point is coming from y equals to x squared. So the lower bound for the y variable giving any x between -1 to +1 is indeed 2x squared. Okay, and then the upper bound on this vertical line again will be stopped at this point. As we said, this point is on the curve represented by y equals 1 plus x squared, which means the y coordinate on this curve is always 1 plus x squared, determined by where you draw this where you drew this vertical line. So this is the 1 plus x. So with this piece of discussion, it is easy to write down the iterated integral. Okay, so let's see if we still have everything on screen. Yes. Okay, I just want to make sure we have the proper recording. So now with this, let's see. We decide we are going to integrate y as the interior variable. and the x as the exterior integral variable. X, as we said, is between -1 to 1. And how about the y? As we discussed, the y is starting from 2x squared and then stopped at 1 plus x squared. So this is how we set up the iterated integral by treating the domain as type 1 region. Okay, so now let's look at it. X is from -1 to +1, and well, we got to figure out the antiderivative, right? So the antiderivative for x plus y dy is, well, this is a constant, so this is x times y, and the y antiderivative, so y squared over 2, this is what we have, right? So we got x times y plus y squared over 2, and then the y variable will be evaluated at 2x squared, and then 1 plus x squared. Then we have dx. Right, so we now could plug in to get x times, remember, this is 1 plus x squared plus y squared, which is 1 plus x squared, and then squared, subtract x times, so now the lower bound, plus again lower bound for y squared, this is what we have. All right, so now let's clear it up. And then we got we have a lot of x, but essentially they are all just some power of x, right? So they are just polynomials of x. And what this is, I think this is I think this is the 1 plus 2x squared plus x squared and then squared, which is the x to the power 4 minus this is 2x cubed plus, well, 2 squared is 4, y x squared and then squared x to the 4, so it's 2x to the 4, I think. Right? Do I have everything right? I think we do. Oh, there's a one thing. I think I copied the wrong integrand here. In the original question, we got 2y, but we actually copy y down here. So let's just change this. Then everything is consistent. Now what? Now this is x plus x cubed plus 1 plus 2x squared plus x to the 4. This is the minus 2x cubed, so this is the x cubed. We can combine those two. This is becoming minus x cubed. This is x to the 4, and then this is negative x to the 4, so this is becoming minus x to the 4 dx. And then we can find the definite integral quite easily. We don't have to compute it, I think, because our main point is to look at the domain. How do we find the domain? So here we do use the graphic illustration that helps us to identify where the domain the integration is. And there's one trick we did use is to find the point of intersection of those two curves. And because those 2 points are actually giving us the interval this x variable is taking value from, and it also tells us how do we determine the lower and upper bounds of y variable if we treat this as type variable. So there are quite a few things that we need to practice with, and hopefully this makes sense to you, and you can start from here by practicing. Okay, let's just pause and we'll continue a little bit later.